Good evening, everyone. Today we complete our topic for Snowflake Cloud features and architects. We did in the first part domain 1.1. Today we will go a little bit to 1.5 because it's kind of relevant, and then we will back to 1.3. So in 1.5, the topics that we will cover is the micro-partitioning, data clustering, table types, and then we will talk about the view types. Let's start. Last time when we talked about the different layers, we talked that the layer of storage where there is a lot of structuring taking place, a lot of automatic clustering and micro-partitioning taking place. Today we will deep dive in that part and we will explain it into detail. What does micro-partitioning and what does data pruning exactly mean? Opposite to the traditional database where data was like stored in a raw formatting, and we give an example for Excel sheets. On contrary, in a Snowflake, the data is differently stored in a column storage format. And that means it make your life a bit more easy, because if you have one column that you need to do any kind of operations that only on that column, the data will go to the specific column and do that kind of calculation or change for the data that you need without touching the rest of data. That creates somehow possibility for better performance. Also, like, we partition the data, so every time the data will come into Snowflake, uploaded into Snowflake or inserted into Snowflake, it will be splitted into files, and this file will be splitted in like between 50 megabyte and 500. You don't need to do anything. That will be happening all down under the hood. You don't see that it's happening, but of course you can reach to that information. Then, like, third part is like immutable. That part is related to the changes that happen. So whatever data is stored in the first version, it will be always there until, even if the changes happen, still the data will be there. So it's right once, it stays there forever. Even if there is some change, then the changes will be like another versions. This allows us two important things: time travel, we will explain it like in this video later on, and zero copy cloning. It means that I can refer to the old version from a different uh, environment without the need that I use again a storage capacity, because I'm just referring to it. I know where it is stored, I just refer to it. Okay. Then we have the pruning engine in a Snowflake. So as we said before, you don't need to do the indexing in a Snowflake, simply because you have this kind of automatic pruning engine that is like working under the hood. So it will take the metadata from your table and create for you the best version of pruning. Remember always the classic uh, like tree for pruning, like when we say if it's bigger than, you'll go to the left or you'll go to the right. It's exactly the same, but in this case, it will be fed by the metadata that is like available in the Snowflake, so you don't need to do anything manually. Let's take a quick example so it remind you with this classic data pruning process that we used to do before manually based on indexing. So let's say that we have a table that have like IDs 1 to 5, age like between 25 and 50, and we will say we will split it into two. So our tree is very small, just two leaves, like one parent and two child. Child MB1, this is like the people under, let's say, 30. So you have column 1 and you have column 2. You have two people like row 1 and row 2. All other above, yeah, under 30, and then above 30, then you have row 3 and 4. If you used a select query with a where clause the age is like equal to 30, it will only scan MB1 child, and it will prune and skip MB2. Of course, that helps to improve the performance a lot. Now let's start by data clustering. So after we understand data pruning, okay, so we will go for the clustering. So naturally data, when it comes into Snowflake, it's like already, as we said, it's partitioned in this kind between 50 to 500 megabytes, and then every group of partition are clustered based on specific criteria. But with a lot of DML operation like update, delete, what's happened? You could lead to some disorganized in your under the hood data cluster. So if the data is really big, like a multiple terabyte table, then the performance could be dragging down. And we need to improve the pruning and the clustering. The cluster, to know that it's like the data is a good clustered, which impact our performance, we used a clustering dips. It's a matrix that measure how much overlap exists between micro partitions. So we have different partitions. The more the partitions are separate from each other, it is like the more pruning is successfully leads the data, and the cluster is in a better situation. So low depths mean good clustering and high efficiency. I have here, this is the official documentation. This photo is really very nice to explain. So the more you have overlapping, right? It's like here in this 5 overlap steps, overlapping micro partition. This is like the worst. This is a nightmare because like you can't cluster, but if you go here to 0, you have the 0 overlapping. This overlap depth is 1. This is the best because you can cluster the data, right, separately in different partitions. So micro partition total is 5. You and the overlap here and the depth is 5, and the overlap here is 0, right? Because you don't have any overlap. This is the best case scenario. This is the worst case scenario. So that's why we say low depths mean good clustering. It means if your depths or like your cluster is 0 depths, this is like very good because it means you don't have a lot of overlap. And this means the performance of your table, any kind of operation will be better, faster, and you will achieve a high performance. And before we go to the third part around, like for the tables, I want to compare between time travel and failsafe because it helps you to understand the difference between different table types because it have a different features for the table. We spoke about its immutable facility that allow us to do a cloning and time travel. Time travel, it allows to access the data that we already dropped. You can enable to access tables, views, or schema or database that happen in past, and you do undropping based on like criteria. You say undrop after dates bigger than these dates, or you will use the ID actually and you will get it back. Duration of the time travel is based on the type of account you have. As we referred last time, if you have a standard account, you could have up to 1 day. If you have like business account or you have like a facility account, then you will have like 90 days. Who can control time travel? You as an end user can control the time travel, and you can do it with just a manual SQL script. It included the cost of it in the data when it's returned. Um, so we consider it as a new normal data that require to be like built. On other side, fail-safe, you as an end user cannot do that. You will need to reach out to one of the Snowflake team to allow you to, from the admin team, to get the data back. This acts as a safe net, so if the time travel in a standard account, for example, is already gone, it's like you are in after 48 hours, for example, and then you can go for the fail-safe and you can get the data. But you cannot do it directly. You'll need to contact support from Snowflake. Limitation, it's only available for permanent table, and of course same, it will be considered part from the storage cost, but maximum you need to know it's only 7 days. So regardless the type, it's only 7 days. Not like the time travel, it really depends on the type. You have enterprise, you have business, or you have standard. Then now we can go to the core table and know what is the different type of table and why we talk about time travel and failsafe. So permanent table, this is a very regular table that you create a table normal statement. You will have between 9 and 90 days time travel, and of course that based on the type of the account you have, and fail safe is only 7 days regardless the type of account. It's critical production data, the only table type with fail-safe protection persists until dropped, explicitly dropped. So this permanent table, just like the regular table, it's like your daily operation. Transit is the opposite. If you don't want to have the data on a permanent basis, um, you will not have the safety net of fail-safe, and it persists until you drop it, but it can be used as in between the ETL and moving the data into your software. Last, temporary, this is only session. Remember, the temporary, it's end by the end of the session. So time travel, you have also 0 to 1, but at the same time, you don't have, of course, like the option of failsafe. And once you end your session, it will be automatically deleted. And now let's move to the new modern tables. So we have the Apache Iceberg, we have the external tables, and we have the dynamic tables. Apache Iceberg, this is a different type that allow Snowflake to expand as a data lake. So it allowed data lake format to be consumed in the Snowflake and built a table format on the top of a data files like Parquet. If you are coming from a Spark background, you might deal a lot with Parquet. Parquet is actually dealing with more complex data than CSV files and JSON. It allows you to consume arrays, maps data, and it's very perfect for the semi-structured data. All that can be used in the Apache Iceberg, and it allows you to handle the storage for such kind of data and store the metadata in your schema. This will allow you to manage it, right? This is the managed part. But be careful because you have the external iceberg. This is the part where the data is stored, and data actually stored physically in your cloud, in S3 buckets, or in Azure, or in Google Cloud. And then on the other side, you have the external table. This is different because this is whole external. So CSV JSON format, but you are stored into the cloud. You are referring to it when you are using as external table. It's only read, and it's slower than in comparison to the internal table, which makes sense because you're referring to an outsource. Dynamic tables. If you remember the old classic way of moving the data between the different layers, writing a store procedure, moving the data using tasks, and then build DAX. Now you don't need to do all of that. All what you need is write a SQL plus a target flag. You set the time, set the clock, and it will refresh the table every 5 minutes. And then you can move the data, or you can reflect it into your BI tool that you want. And then we have views, and this 3 type of views. We have the standard, we have the materialized, and we have the secured. Standard is allow you to do the normal operation, but if it's a little more complex, then you need a physical stored. We use the materialized view that allow to do the more complex, that require more computational power. And you have also the secure view. Secure view can be both standard and materialized. Both of them can be secure view. You add that for data privacy to allow privacy, so there is no data leakage from your view.